Next up, we have Mr. Ed Eby, who is going to talk about water resources in southern San Luis Obispo County. Ed is director of the Nipomo Community Resource District.
What is our water supply in the south central coast area? I've given a portfolio here of water of different municipalities from San Luis Obispo all the way to Santa Barbara. And the important thing to notice is the variety of sources of water for each of these municipalities. San Luis Obispo, the city, is in the best shape because they have 5 different sources of water. If any one of those sources gets weak, they have other ones that they can draw from. Similarly, most of the municipalities either draw from Lopez Lake, State Water Pipeline, or groundwater. I'll talk about the South County, which is where I live, and show you where we get our water. Pismo gets their water from groundwater wells. They have a draw from Lopez Lake, and they get water from the State Water Pipeline. What's interesting about this is they're limiting the amount of groundwater they're taking because of the concern for seawater intrusion. Lopez Lake is at an all-time low since it was since Lopez Dam was first built. They have an emergency water plan right now that if the drought goes 2 more years, like it's gone in the past, they will have what they call dead pool, and they won't be able to draw any water out of Lopez Lake. And then finally, they get water from the State Water Pipeline, which, by the way, dumps into Lopez Lake. So that's how they get that source. Grover Beach has groundwater and Lopez, as do Arroyo Grande and Oceano. Oceano also gets State Water Pipeline. Nipomo, where I live, is a different situation. We have had only one source of water, and that's groundwater. We have negotiated with the city of Santa Maria to build a pipeline from Santa Maria to connect their city water system to Nipomo, and as of July of last year, we're starting to pump water from Santa Maria, the city of Santa Maria, to augment our groundwater. Groundwater that we get, all of us people in the South County, essentially comes from the Santa Maria groundwater basin, which is outlined in red. It stretches from Sisquoc to Shell Beach, all the way down to Point Sol. The water is collected from the watershed around these mountains in this area, comes down Sisquoc Creek, and it also collects behind Twitchell Dam and joins to form the Santa Maria River here. This is a very deceiving picture because it looks like we've got all kinds of water in Twitchell Lake. That's what it looks like after gigantic rains. Most of the time, Twitchell is dry. Right now, it's essentially dry. When it does fill up, what the dam operators do is they have a limited release of water from the dam, and the way they control it is they let water run down the Santa Maria River until it gets to Bonita School Road right here, and then it finally sinks into the ground. So they control the flow that the river is only active when it's controlled, when the water is flowing to here. And after it goes dry, obviously, the Santa Maria River is a dry riverbed, which on average it flows 3 or 4 days a year. And when it flows, it flows. The city of Santa Maria is right in this area. Nipomo Mesa is up here. We have a connection to the Santa Maria water supply through a pipeline that comes up Blosser Road, under the Santa Maria River, and I mean under, 100 feet deep is our pipeline, up onto the mesa, and then it hooks into our system. We have a pump station that pushes it to the rest of the Nipomo Mesa. We just completed that pipeline early last summer, and water has been flowing since July 2nd, and we're pulling water from Santa Maria at about 500,000 gallons a day, which is currently it's about 650 acre-feet per year. I'm going to talk mostly about the Nipomo Mesa because that's where my knowledge is and that's where I'm from. So let me talk a little bit first about the water balance. Since we have such a large dependence on groundwater in Nipomo, we're concerned about the water level in the mesa, the level, we call it a water table. So that's this thing here we're worried about. The sources of water for the Nipomo Mesa is rainwater. A certain amount comes per year. We have subsurface flow that comes in from the Santa Maria River Valley, and a little bit comes in, we think, from Nipomo Valley, which is to the north of us. The water goes out primarily from pumping. Total extraction is pumping. A little bit leaks out to the Rio Grande Valley, and some of it leaks out to the ocean. Because we have percolation and septic systems, a certain amount of the water is returned as a return flow. So as you can see, we want this to be in balance, because if we're taking out more than we're putting in, this water level will drop. If we're lucky and we're getting a lot more rainwater, then that level will go up. So that level, as I'll talk about in a minute, is really important. As you've heard, we've had a drought. This is a 40-year rainfall history on the Nipomo Mesa. The average water level or water rainfall is 16 inches per year. As you can see, we've had many years below and a few years above. When it's above, it's really above. And when it's low, below 16 inches a year, it's really low. And we've had 4 years of drought now. The worst one was the year before last. It rained a little bit last year, so we got a little bit more, but we're still well below the average. Gentleman mentioned earlier that we're really in 9 years of drought with a couple of good years. Well, there's a couple of good years, and sure enough, most of the years is below that. How do we use our water on the Nipomo Mesa? This is a picture that was put together by a group called the Nipomo Mesa Management Technical Group. It's a court-recognized group of water experts that came out of the Santa Maria Valley lawsuit, which is still underway. But this technical group makes a report once a year to the court on the status of water in the Nipomo Mesa area, which is this area here, the Nipomo Mesa Management Area. And in it, they tell how the water is used. Okay, the green, which is you are probably most interested in, is agricultural use. Down in this region, it's mostly strawberries. Over here, out on Mesa Boulevard, it's a lot of strawberries. This is strawberries here. I think there's some avocados up here, and there might be some avocados up in this area.
Where would Willow Road be on that?
Beg pardon?
Where would Willow Road be on that, do you think?
Willow is it's right around here. It's right along this line here. So I know there are a lot of avocados growing in Nipomo, but not on the Nipomo Mesa. Most of the avocados that I know about are grown up here, which is outside them, off of the mesa, in what we call the Nipomo Valley, even though I think the avocados are grown more up on the valley. I know Fugate has some up here, and a lot of lemons and avocados are grown outside of this area. Like I say, I think there is some avocado over here. Most of what you see, though, is urban use. The brown is generally non-irrigated and no use at all. Then the deeper purple colors are the water purveyors. This is the Nipomo Community Services District, and this deep purple that provides water, a little bit of water on that side of the freeway and a little bit up here, and then we provide water up here. Golden State Water Company is this area. They just bought Rural Water Company, which is last week, which is this area over here. The Woodlands, which is a new development of Trilogy, the Woodlands, that's this area here. So we've got basically 3 water companies municipal water companies on the mesa to provide urban use. Now, what is the water situation on the Napomo Mesa? The Department of Water Resources put out a report in 2002 on the Napomo Mesa geology, hydrogeology, and so forth. And in that, they said that the dependable yield on the Napomo Mesa is between 4,800 and 6,000 acre-feet per year. That's this line right here. Dependable yield means you can draw that much out of your aquifer on average over a period of years with no harm to the aquifer. In other words, the overall well levels don't drop too far. You don't have seawater intrusion. You don't have subsidence and all the other bad things that come with pumping too much water. As you can see, over this period of time, we started exceeding the dependable yield at this point in about 1984. Now, you've heard that these bad agricultural users are robbing 80% of the water and only 20% goes to urban. Well, that's not exactly the case on the Napomo Mesa, because this is ag use and this is urban use. So the ag use has stayed roughly constant over this period of time, but the problem has been in the growth of urban. We've had a tremendous growth in houses. Over that period of time, there have been 3 golf course resorts put in, which brought with them both houses and golf courses. The golf courses use a lot of water, 1 to 3 acre-feet per acre of golf course, and the golf courses probably use more water than the houses on the golf course resorts. So what this is showing here is that the urban water consumption just from 2000 to 2008 went up 50%, whereas we crossed the dependable yield here. So you can expect there might be some effect on the water table on the Napomo Mesa. This, again, just shows the area of the Napomo Mesa that we're talking about and the water companies, the 3 water companies that are involved. NCSD here, and then Golden State at this point, and Golden State bought Rural, which is these areas here, and then Trilogy has its own water company right here. These water companies, of all of the water on the mesa, they only provide 40%, they only draw 40% of the water from the aquifer. The rest is either ag or individual wells on individual properties, which is all of the properties that are out here that are not served by that, and the golf courses. The golf courses are not counted in the water purveyor water, because most of the golf courses have their own wells, so they're using their own individual well water to water the golf course. The Woodlands Mutual Water Company provides water to the residential houses. There are separate wells for the golf course. And there's a couple reasons for that. One is you don't have to treat the water as carefully for golf course as you do, or for ag as you do for human consumption. This group called the Napomo Mesa Management Area Technical Group, in order to report accurately to the court the status of the water on the mesa, has developed a scheme where they took a look at a lot of wells on the mesa, and they established that some of them, because of their behavior, they're going to call them key wells. They're in critical parts of the mesa, and when these wells were selected such that if you have an anomaly on one well where it goes way down or way up, it doesn't affect the overall average of the key wells. And what we're trying to do here is get a general health of the mesa wells by just looking at a few wells rather than the 500 that are out there. And so they've developed a thing called the Key Well Index, and this takes a weighted average of all of the wells' water levels above sea level. And they looked at 2 criterion. One is a potentially severe criterion, which is at this level, it's 31.5 feet, and then a severe criterion, which is about 16 and a half feet. What this means is this level was chosen because this is the level at which if you're essentially dropping below that level, you're falling into the area where you're getting the effect of being beyond the safe yield. And so something needs to be done. So when you drop below that level, certain measures are put into effect by the Nipomo Mesa Management Area Technical Group. They ask the purveyors to cut back on water. They have certain water conservation techniques that kick in. The severe criterion is based on the fact that over the 40 years that they've been looking at these wells, the average water level in those wells has never dropped below them. So as you can see, when we had some good years and before we had a big population influx and a lot of houses and a lot of golf courses, we were up above the potentially severe. But as we got into time, got into the effect of using more water, urban water, in the golf courses and in the houses, we started dropping into this potentially severe region. That one year that popped up that looked like it was a good year in the middle of the bad 9 years, that's the effect that had. It only went up that much. But then the last 4 years, this is what happened. We dropped down to average well being 10 feet above sea level. That triggered the severe criterion, which the water purveyor said, okay, that's it. We're not hooking anybody else up until this condition, until we get above this condition for 2 years. And so at the current point, and since May, the Nipomo Community Services District has stopped accepting applications for new water connections. And at the same time, remember, this is a point where we had a lot less consumption because we had a lot less houses. Now when you have more houses and you have a big rain year, it doesn't help that much because you got a lot more use. So you're draining the pool faster out here than you were here. So you,
from 14 to 15, we had more rain in 15 than we had 14. We haven't had that much difference in housing on Nipomo Mesa between 14 and 15. Why do they see that drop happening there?
well, this is the one that you should ask about, because why did it go up when it was a down year? And we think the reason this happened was we had the rain that year in the first part of April. These measurements are taken once a year. They're taken in the middle of April. And if you had a rainstorm 2 weeks or a week before those wells were measured, they probably recovered some. And that's what we think happened here. We think because we had an April rain and the measurements were taken in April, we think that went up there. But then last year, this was a 4-inch year. I can't remember what the rainfall was that year, but then this in 15, which was last April, this is what we had. You see, in 15, as I remember, we had most of the rain was in December, and then from January, February, there was nothing. So those wells that are measured in April had 4 or 5 months worth of no rain. So you could kind of expect that. Okay, so what if the water level drops? Well, if you had a shallow well in the first place, that means you got to go deeper in your well. The deeper you go, the lousier the water quality is. As you know, the deeper wells have higher total dissolved solids in them. If you're next to bedrock, suppose this is the bedrock here, and the pool of water was here. If you're next to bedrock and the water level drops down there, well, even if you drill to the bedrock, the water has dropped below where you are. And there are places in Nipomo where the bedrock comes clear to the surface. And finally, the worst thing that can happen, of course, is seawater intrusion. Talk a little about seawater intrusion now, how it happens and what it means to you. Normally, when you have lots of rainfall, you have a water table that's up like this. And when that's the case, if you're next to the ocean and you share the aquifer with the ocean, essentially the bedrock is down here. So your aquifer is being shared with the ocean, and you'll have this transition zone or interface right here where it's mostly seawater over here, mostly freshwater over here, and there's a mixture in between. If this water level is high, it keeps enough pressure and flow out to the ocean to keep this interface farther out. What happens when your water table drops down to this level is it allows the interface to come back in farther, and you don't have the fresh water pushing that seawater back, holding it back. So wells that you have that are closer to the ocean, are going to be drawing in seawater or water that's nearly as concentrated as seawater, whereas inland you're probably okay. But this is why you don't want your levels to drop too low, is because you're not keeping the sea level back. Has seawater intrusion ever happened? Yeah. Up in Monterey, since 1944, they have been measuring seawater intrusion. It was this far inland in 1944, and these contours are defined as the water directly below you in the 180-foot aquifer has a concentration of 500 milligrams per liter of chloride. Seawater is anywhere from 20 to 40,000 milligrams per liter, but this shows that seawater is coming in. Normally, if your water is greater than 500 milligrams per liter, if you're a water purveyor, you can't provide that to your customers because it's too salty. And a lot of plants won't even survive with that level of saltiness. So up in this area where they had the seawater intrusion, they had all kinds of problems with their crops. In fact, I talked to one guy up there, an artichoke farmer, and the artichoke farms are right along here, and they're just like the dunes are. The water's here, the dunes are here. Just over the dunes is the artichoke fields. And this artichoke farmer told me that his artichokes weren't doing too good, and he went out there one day, and this is when they had sprinklers, and the sprinkler hit him in the face, and he could taste the salt water in it. So they knew they had a problem. So what they did is they built a giant water reclamation project, which takes all the sewage from all of the surrounding cities and processes it to where it can be used on the plants. And all of the plants in this whole area, all of the crops, use that reclaimed water. And they only use it because the groundwater below them is too salty for their plants. But as you can see, over the years, this seawater intrusion has drawn in because the people here are drawing their groundwater down, and it's allowing the seawater to come in. This is what you don't want to happen unless you want to end up using only reclaimed water for your water supply. And if, for example, you're pumping groundwater and it costs you $300 an acre foot to do that, getting the water from a reclaimed water source is going to cost you well over $1,000 an acre foot. Okay, this is another example of what's happening in Monterey. The aquifer isn't just one homogeneous bowl of water. There are layers of clay at various levels, and these layers of clay separate the different aquifers. So directly below you could have several aquifers. In Monterey, they have what they call a 180-foot aquifer, they have a 400-foot aquifer, and the deep aquifer. And here is the fresh water coming in, holding back the ocean. At this aquifer level, you can see the seawater has come in this far. At the deeper aquifer, it hasn't come in as far. And then finally, at the deepest aquifer, it's pretty far back. But depending on where your well was, if your well was here, you're out of luck. If your well was here, you're probably okay for a while. But that's the way it works. These, by the way, you might have heard the term perched aquifers. This is a perched aquifer because it's perched above this clay level. This is another perched aquifer. Okay, closer to home, Los Osos, we also have seawater intrusion. and there's a zone called Zone D where the concentration of seawater is like 250 milligrams per liter. And this is how it has advanced. In 1985, this is how far the seawater had advanced underneath there. 2005, and it keeps going 2009, 2014. These are wells, and there are various monitoring wells and production wells. So you can see that this production well is no good anymore. It's been contaminated by seawater. Same with this. Same with this. Out here, this guy is still okay. But as the seawater advances, your wells become less productive, and you have to go farther inland to get your water. Here's another shot just to show what the seawater intrusion is. It doesn't especially come in a straight line or a front. It takes opportunistic paths inwards. If the soil is more porous, the seawater is more able to come in quickly in what I call fingers. And again, here's the different layers. Here's in Los Osos, this is a clay layer here, another clay layer here, and you can see how the seawater has advanced over the years. Again, here these are wells. This well obviously is no good at that level, it's no good at that level, or at any other level because of the seawater intrusion. And here is an example of, in a different look of that water coming in, not evenly across the front, but in opportunistic fingers. And this, by the way, is 2 miles from here to this point. Okay, so we don't want seawater intrusion. What causes it? You're pumping too much water, you're not getting enough rain. So you don't want to not pump water because you need it. I mean, you can't conserve your way out of these dilemmas. So what does it look like for rain? Well, I made this chart 2 weeks ago, and when it hadn't rained for several months, and as you know, it rained yesterday. NOAA predicts what the weather is going to be like several months in advance, and if you go to this website, you can get the figures that I'm going to show here in a minute. Okay, what this picture looks like at that website, they give you a year's worth of predictions. What they give you is probability of rainfall exceeding the normal. Now, for the normal in Nipomo would be 16 inches of rain a year. What this A means is above average, B means below average. So if you're in this region where we are, will it rain in December? They say it's between a 33 and a 40% probability that it will exceed the normal rainfall as they've measured it over the last 30 years. If you happen to be farther south, it's between 40 and 50% probability that it'll be greater than normal. Now these are updated once every month. This one I took from the October 15th update. There will be another one November 15th if you want to go to that website. Okay, so that's December. It looks a little bit better than normal. January. Well, now we're between 50 and 60% probability of more rainfall. That's good. February. Well, again, we're 50, 60%. If you were down here, you'd be above 60% probability of being greater than normal, and that's really good if you live down there. March, still pretty good. It's above 50% more probability of above normal rainfall. EC, by the way, that means even chance. That would be the average. They can't even guess there. April, well, we're still a little bit. We're in the 33 to 40% region. And May, well, you better have collected all your water by May because it's going to be whatever's normal. So we can't do anything about the rain. We can look at predictions and hope that's what it'll be. But what sort of projects can people do to increase their water supply if the rain isn't doing its part? The main thing you can do is get supplemental water. That means water from outside your area. It doesn't mean taking it from your neighbor. It doesn't mean taking it from your lakes. It means getting water from outside the area that wasn't normally available to you. In Nipomo, we have this Santa Maria pipeline that I talked about. It's currently sized for 650 acre-feet per year. It cost us $17 million to get to that point. The system can grow to 30,000 acre-feet per year at a total cost of $40 million. Now, we're under court order with this lawsuit that I mentioned earlier. We're under court order to provide 3,000 acre-feet per year. We'll do that over a period of about 10 years because we tried to fund it all at once for the property tax assessment, and guess how the voters voted? So we went back to the drawing board and found another way to fund it. Rather than funding it all at once, where it would have cost us $27 million, we found a way we could slowly fund it over a period of 10 years. But the cost is going to now cost $40 million to do that. The pipe that goes under the Santa Maria River, that was our most challenging part because we had to go 100 feet deep underneath the river using hydraulic directional drilling under the river to send this pipe under the river. And just to meet the curvature and so forth, it had to be 100 feet at some depth. That pipe, since we knew that was the most challenging part of it, we sized that pipe so that it could take 6,000 acre-feet per year. But you'd have to build the rest of the infrastructure to do that. Currently, our contract with the city of Santa Maria is only for 3,000. So this could be done, but it would cost a lot more money. It would take another agreement with the city of Santa Maria, and we'd have to do more to the rest of our system. Another little sneaky guy hanging out there is the State Water Project water. Right now, water comes from the Central Valley over a pipeline through Polonio Pass in Northern County, and then comes down and feeds various people along the way. Lopez Lake, like I mentioned earlier, gets it. Santa Maria gets a lot of it. It goes all the way to Santa Barbara, where the terminus of the pipeline is, and there it dumps into Lake Cachuma. All of the people who paid for the pipeline along the way have a certain amount of property tax that's paying for that right now. The county of San Luis Obispo paid for 19,000 acre-foot per year of that. They're taking about just a fraction of that. The problem is the treatment plant in Polonio Pass. The water treatment plant is only sized for the amount of water that's going through it right now. They would have to increase that treatment plant, and then San Luis Obispo County could get its 19,000 acre-feet per year. But it's not doing it, and there are no plans in the work for do that. That's an opportunity that we can get for water that we're paying for anyway. We're paying for 19,000 acre-feet per year even though we're not using it. Then everybody's favorite is Desal. People say, well, you got that ocean out there. There's no limit amount of water. That's true. But there's a limit to other things. Big limit is called the Coastal Commission. We know that it's economical. We know how much it costs to get desal water from the ocean. There's enough plants operating. The engineering is very mature, so we know what we're doing there. But getting past the Coastal Commission, which requires that you don't harm sea organisms in the ocean as a result of desal, is the trouble. When you draw in water with an open ocean intake, like most people around the world do, you also draw in fish eggs and microscopic organisms, and it probably kills them. And then on the other end, your brine, when you make fresh water out of seawater, you end up taking 1 gallon of seawater and turning it into a half a gallon of fresh water and a half a gallon of salt water that's twice as salty as it was before. So that salty water coming out into the ocean, the environmentalists are afraid that salty water is too salty for the animals that live there, and it'll kill them. So they say if you're going to discharge your brine into the ocean, you have to disperse it in such a way that it doesn't harm the organisms. Those two things, the intake and the inlet and the outlet, are the two issues that makes desal so expensive, and it makes it almost impossible to achieve. Diablo Canyon, the nuclear power plant, has a little desal plant to give pure water to their boilers. It only is currently using 500 acre-feet per year. It's sized for 1,000 acre-feet per year, and it could go up to 1,500 acre-feet per year. So if they only need 500, it's possible they could provide out of that plant 1,000. San Luis Obispo County is looking at that and looking at getting additional excess from the Diablo's desal plant, pumping it into the South County. And right now they're looking at what it'll cost to do that. Pipeline of 7 miles. Generally, pipelines cost $1 to $3 million a mile. So you got a good pipeline cost there if that's the way they go. In January of 2016, they're supposed to get a good estimate of what it's going to cost them. The NCSD in a 2007 study looked at desal. We figured a plant that would give us 6,000 acre-feet per year would cost $100 million, and the water from it would cost $3,600 an acre-foot. Monterey right now is under court order to build a desal plant. I was up there a few weeks ago and got a tour of what they're doing, and they're not doing much. They're in the very conceptual stages right now. But wherever they are, they believe that it's going to cost them $300 million to build the plant, which will give them 6,000 to 9,000 acre-feet per year at $3,000 an acre-foot. They're supposed to have that online in 2020, but knowing how long these things take, I think they're 10 years away easily from doing anything. You've probably heard about the new Carlsbad plant. That isn't really applicable to our case because that takes in brackish water. They don't have to deal with harming the organisms or the brine. They take the brine and they put it out through the power plant outfall, so that's already been taken care of. So you can't look at the cost of the Carlsbad plant to compare it to ours. It's a $1 billion plant, but it puts out a lot more water. Finally, everybody's favorite is wastewater. You're throwing all this water into the ocean. That's true, but you're throwing a limited amount of water into the ocean. And if you could reclaim all of that water, there's still a limit, as opposed to the ocean where it's unlimited. So whatever your sewer plants are putting out, then that's the limit of what that particular supply of reclaimed water is. We did a study earlier on what it would take to take the NCSD sewer plant and convert it to reclaimed water. It would cost $15 million to do it. We could get 1,600 acre-feet per year out of it, but there's only about 600 acre-feet per year that the plant could put out. So it would cost you $15 million to get 600 acre-feet per year. South County Sanitation District, which is Oceano, Grover, Arroyo Grande, and Pismo, they all have a sewer plant that's down by the Oceano Airport. They send out 3,000 acre-feet a year into the ocean. They're looking right now into getting a price for that. They've done it in the past. They've looked at the price, but it's 10 years old, and so it's a stale estimate. And then finally, Pismo is looking at cleaning up their water from their plant and then putting it into groundwater injection to keep seawater from being a problem there. That study is underway. It's been underway under various descriptions for several years. But again, reclaimed wastewater is almost as expensive as desal. A couple of problems is you essentially have to go through all of the processes of making the water sanitary, and then it's still salty. It has a lot of brines and dissolved solids from the sewer plants. you essentially have to desal that after you've gone through all the decontamination.